This video will be about lines in the coordinate plane. So when you're working with a line, there's three main equations that you can use. There's standard form, which would be ax plus by equals c. There is SlopeIntercept Form. That would be y equals mx plus b. And there is Pointslope Form. Y minus y1 equals m times x minus x1. They all have their various uses. Some are better in different situations. This one is better for graphing. It's better to make a graph. This one is better if you're finding the equation given a point and a slope, or given 2 points. And this one is good for finding x and y intercepts. So let's start with standard form. Let's say we have 3x minus 4y equals 12. This is in standard form because both the x and the y are on the left side of the equal sign. So when you're in standard form and you want to find the x and y intercept, and then graph it, to find the x-intercept, y would be 0. So if we made y 0, that basically means this whole piece here is going to go away. So to find the y-intercept, sorry, I said the wrong one. To find the x-intercept, right now we're doing x-intercept, basically the y piece is going to go away, and you're just going to have 3x equals 12. This is really 3 times x, so to get x alone, we do the opposite, which is divide by 3. So the x-intercept would be 4. Now to find the y-intercept, we would make x 0. So 3 times 0 minus 4 times y equals 12. Again, basically it just means this x piece is going to go away. We have negative 4y equals 12. And again, we'd have to divide, since that's really negative 4 times y. So my y-intercept is negative 3. So now that I know my x and my y-intercept, I can get a graph. The x-intercept is where the line crosses the x-axis, and the y-intercept is where the line crosses the y-axis. So that means x equals positive 4 on the x-axis. Positive 4 is here. On the y-axis, we cross at negative 3. Negative 3 on the y-axis is here. And if you connect the two dots with a straight line, you have your line that goes with that original equation we started with, 3x minus 4y equals 12. So the second type of equation was when we were in SlopeIntercept form, y equals mx plus b. In SlopeIntercept form, the m is the slope, and b is the y-intercept. So let's say we have y equals 2x minus 3. That means the number in front of x, 2, would be the slope, and the number behind the x, negative 3, would be the y-intercept. That is enough information to draw a graph. So when you draw a graph in SlopeIntercept form, it's a little bit different than in standard form. Standard form, we found the x and y intercepts and just graphed the x and y intercept. In slope-intercept form, we still graph our y-intercept. That's where we cross the y-axis, so at -3 we have a point. But then our slope will tell us this is the pattern you have to follow to get to the next point. When we had the x and the y-intercepts, we could just say, oh, there's a point here, there's a point here. Here, we know our starting point, -3. The slope has to be a fraction, and if it's not already a fraction, we could put it over 1 to make it a fraction. And the slope always goes rise over run. That means we're going to go up 2 over 1, and that would give us our next point. So counting from here, we count up 2 over 1. That gave us our next point, and once you have 2 points, that's enough to draw a mostly straight line. It should be perfectly straight, but I'm drawing this by hand. So with these format of slope-intercept, there is 2 special kinds we should talk about. There's one where it's just y equals a number, or another where just x equals a number. So these are special, and you need to have these memorized. When you have y equals any number, I picked 5, but it could have been 3 or 2 or -100. Doesn't matter. This will always be a horizontal line, and it will always have a slope equal to 0. So if we were to graph it, just have a horizontal line at +5. Sorry, I meant to make that a different color so you could see that it's not part of the coordinate system. If it's x equal to a number, that's a vertical line every time. And the slope is undefined or no slope. So x equals -3, we cross at -3 on the x-axis. And again, we have a vertical line, so it's going up and down. So what can happen when you are working with this slope-intercept format is they may start you out in standard format, and want you to go through and change it to slope-intercept form. So to change this to slope-intercept format, first we need to get the whole x piece on the other side. If we want to move the 2 and the x, we look at the sign in front. If nothing's written there, we know this is positive. So we'd have to minus 2x from both sides. Now 9 and 2x are not like terms. We could not actually write them together. So we just write them side by side, but in slope-intercept form, we want the x to come first. So I'm going to put -2x first. Next, we have the -3 times y. This time we only want to move the 3, which means we have to divide. But we divide all of them by -3. So this gives me y equals a negative over a negative is positive, so +2 over 3x. 9 divided by -3 is -3. Now that we have it in slope-intercept form, we can graph this. So again, each number represents something. M is the slope. M was in front of x, so that's our slope. B is the y-intercept, so -3 is our y-intercept. So we go down to -3 first. You graph the y-intercept first. And then the slope, since both are positive, we would go up and to the right. If it's ever negative on top of a fraction, you'd go down and then to the right. So we go up 2 spots and to the right 3 and have our line. So the last form was Pointslope form. Y minus y1 equals m times x minus x1. Pointslope format is good if they give you a slope and a point. Let's say we want the equation of a line that goes through the point 2, -1 and has a slope of 5. The numbers in the equation we have to replace are y1 m, and x1. M still stands for slope, and in a coordinate we always know x goes first, y goes second. In this case we're calling them x1 and y1. So we'd have y minus y1, so y minus negative 1, equals m, which is 5, times x minus x1, which was 2. Now if you have a minus minus next to each other, you do have to make it a plus. Now it looks like on the assignment most of the time they're leaving the answer like this. If it doesn't leave it like this, you can simplify and change it again to slope-intercept form. There's often, slope-intercept is the best for graphing, so we often have to change them to slope-intercept. So in case, so you may have to stop here, but in case they go further, what you do is you distribute on that side, so we'd have y plus 1 equals 5 times x is 5x, 5 times negative 2 is negative 10. And then you just want y completely alone, so we'd minus 1 from both sides, and we'd get y equals 5x minus 11. So if they want you to write it in slope-intercept form, you can do that. The last thing you can do with point-slope form is they could give you 2 points. So if they give you 2 points, they didn't give you a slope this time, you have to find it. If you're going to have to find slope, we need one last formula. Slope, when you're given 2 points, it's still rise over run, so y values over x values, but you have to subtract them. So again, every point is x and y, and the reason we even have this, sorry, I was thinking of the next thing I was going to talk about. So the reason I wrote a 2 there is because the reason we even have this little 2 below and little 1 below is to say, well, the first point, I want it to be a different x than the second point. So the first point I'm going to call x1, the second point x2, the first point y1, the second point y2. Then we can plug those in to find the slope. y2 is 4, so 4 minus y1 is negative 1, over x2 is 5 minus x1 is 3. Negative negative makes this really a plus. 4 plus 1 is 5. 5 minus 3 is 2. So now we have a slope. Now, once we have our slope, we can actually use either of these points to get our equation. It doesn't matter which one we pick, except that when you're doing multiple choice, you're going to have to look for the numbers here that they may have already used in the answers. So multiple choice, you have to decide, well, does it look like they used the first one or the second one? I'm going to go ahead and use the second one. So we plug in y minus y, this case y2. I guess maybe I should have picked this first one just so we were sticking with the x1, y1, but again, it doesn't really matter. You can just plug in the x and y value into this equation. So y value is 4, slope is 5 over 2, times x minus the x value of 5. We'll go ahead and leave it like that since we already talked about how you could simplify it. So that covers everything for lines in the coordinate plane.